All right, today we are going way back to a truly pivotal moment in database history. We're going to talk about how MongoDB went from this brilliant, but let's be honest, kind of limited single server tool into a genuine distributed powerhouse. This, right here, is the story of the 2.x series. So to really get this leap, you got to picture MongoDB 1.0. The flexible document model, oh, it was a game changer. A total breath of fresh air for developers who were sick of rigid schemas. But, and this is a huge but, it had one massive architectural bottleneck. Every single piece of your data had to live on one machine.
And this created a really fascinating paradox for anyone who actually got popular using it. I mean, think about it. Your app takes off, your user base explodes, data is just flooding in, and suddenly your own success becomes your single biggest problem. What do? That one server, it becomes the ceiling you just can't break through. You start running out of disk space, you're out of memory, and worst of all, the thing that keeps you up at night, you have a single point of failure. If that one server goes down, your entire app, everything, it just goes dark. The community wasn't just asking for new features. This was a desperate cry for a way to scale and survive.
And the answer finally arrived with the MongoDB 2.x series. Between 2010 and 2012, these updates weren't just tweaks. They were a fundamental rethinking of the database's architecture. They brought two concepts to the table that would change absolutely everything: sharding and replica sets.
So let's tackle the first big idea, sharding. See, if you can't just keep making your one server more and more powerful, that's called vertical scaling. The only other option is to just add more servers. That's horizontal scaling, and sharding was MongoDB's genius strategy to split the data and conquer the scale problem.
So what is sharding exactly? Well, the easiest way to think about it is like this. Instead of having one enormous central library that's totally overwhelmed, you break it up into a bunch of smaller, more manageable neighborhood branches. Each branch, or shard, holds just a piece of the total collection. This makes it way faster to find what you're looking for and make sure no single building gets completely swamped.
Now, what's really cool is how elegantly MongoDB pulled this off. I mean, it's not enough to just split the data randomly. You need a system. So first, you had a config server that acted like the master map, the central card catalog for the whole library system. It knew exactly where every single piece of data lived. Then you had a query router called Mongos. This was like the super smart librarian at the front desk. It would look at your request and instantly tell you which branch to go to. This whole three-part system is what made sharding a real production-ready solution.
Okay, but scaling out only solves the size problem. What about reliability? What happens when one of those library branches suddenly, has a major flood? That brings us to the second pillar of the 2.x revolution, replica sets. This was all about resilience.
And wow, this slide just shows you the night and day difference. Before, you had a single point of failure just waiting to ruin your day. With replica sets, you got this magical thing called automatic failover. The system could actually detect if the main server went down and within seconds automatically promote a backup copy to take its place. No frantic calls in the middle of the night. This meant you had data redundancy and a massive, massive leap in availability. You could even use those backup copies to handle read requests, giving you another way to scale.
So here's the crucial point. You put sharding for scale and replica sets for resilience together, and what do you have? All of a sudden, MongoDB was ready for prime time. It wasn't just a cool tool for developers to mess around with anymore. It was a serious contender for major production workloads. And this just unlocked a whole new world. Suddenly, developers could confidently build high-traffic web apps, massive big data platforms, and super resilient real-time systems on MongoDB. We're talking about the kind of mission-critical projects that would have been way too risky or just plain impossible on a single-node database.
You know, the impact here went way beyond just MongoDB. This was a real turning point for the entire NoSQL movement. For years, the big knock against NoSQL databases was that you had to trade reliability for that nice flexible model. MongoDB 2.x just started to tear that whole argument apart.
And this quote, it just captures that shift in thinking perfectly. The 2.x release has proved to the world that a database could give you a flexible, developer-friendly model and be incredibly robust, scalable, and reliable. NoSQL was finally growing up.
Of course, the story didn't end there. With the challenges of scale and resilience conquered, the next frontier was raw performance and concurrency, how to handle tons of operations all at the same time. In our next deep dive, we're going to see how MongoDB 3.0 and the acquisition of the Wired Tiger storage engine completely revolutionized the database's core all over again.
But the lesson from the 2.x series is just as relevant today as it was a decade ago. It gave developers a real map for how to scale. It proved that true scalability isn't just about handling more data, it's about having a deliberate, thought-out strategy for growth and for resilience. So the question I want to leave you with is, what's yours?